let's go to record 630 course schedule 3. For this question, it gives us a two-dimensional array courses. And for every course, this array, it gives us the first element is the duration. And the second element is last date. So for example, for this course, it takes a student 100 days to finish or 100 hours to finish, and but it need to finish at 200 days. So it asks what's the maximal courses you can take. So what we're thinking about is that we should greedily take the courses. For example, we add the course which end for example, we add those courses one by one, right? Let's look at this example. We add the one it take 100 days, right? So this one is finished before 200. So we take this one. And then the second course, for example, it take 200 days. So we put here. And now the finish date, the 300 is still smaller than 300. Then we take 1000, right? 1000. And let's see. If we take this course, it need to if we need to finish this course, and in the case we want to finish it, right? So we need to finish this course before 1250, right? That means we cannot take course 1, course 2, and course 3 together because this one exceeds the last end date. So if a user he want to take as many courses as he can, so what kind of, if you will see in this case he has to get rid of one of the course out. So in this case, if we want to take one of the course out, so what kind of course he need to take out? I think the one which use the longest duration we should take out, because if we take the out of this, right, we have it give us more space to start from for other courses. So to take out this course, the longest duration one will be more efficient if he has to take 2 courses. So what we're thinking about is that we can use some kind of priority queues, right? So the queue will sort, for example, sort by the duration, right? So we add those kind of courses one by one, and if those courses, the total time already exceed those kind of course and time, then we get rid of the maximum duration one, right? So we need to use a priority queue, which is have a reverse, use a max heap to sort by the duration in a descending order. And for the course we take one by one, we should sort by the end time, right? Because if the first one we can we can put that into it, right? Because if we do not sort by the end time, if we we just greedily we should want to take the course which do not exit the end time. So the one we take, we should we try to this give us the ability those kind of course will not if the end time which is smaller, this give us more the ability that this course can be taken, right? So we should think about the two steps. One is to sort by end time, and another is to use a priority queue, which will sort in a descending order of the duration. So we add, then we use a total variable called current end time or something, right? And then we iterate those kind of cost array. And once we added that, right, we get the every current time. If it's not we put this one one by one to the priority queue, right? So if our current end time is already, for example, when we calculate is already, if we want to add this one, right? Current end time will be 130. It is bigger than the this course end time. That means we need to get rid of the largest duration from this priority queue. And in the end, when we finish the iteration, we just check the size of the priority queue, trying to see how many courses are in the priority queue. And in this case, we are making sure that all of the courses, when they add up, the end time or current time is smaller. Current time is smaller than this course end time, and also we use the most efficient way, right? Because we get rid of those courses which have the bigger duration time. In this case, we just calculate the priority queue size, which will return the maximal courses a user can get. So let's begin to write code for this. For this one, we need to sort the course, right? So we need to sort by its end time. Always sort courses. If that is the end time, that is A, B goes to integer compare A1, B1, right? In that is a sort of course by end time in ascending order, right? And now we trying to say use a priority queue, okay? Priority queue. We're trying to put those courses into the priority queue. And what we need, we just need to put those kind of durations, right? I think just one dimension should be enough. Let me think. Yeah, I think for this priority queue, we just put those kind of courses with its durations, right? So we call maxi equals to new priority queue. And for this one, is that we try to put the duration is it? As we every time if we want to get rid of some of the costs, we just want to get rid of those costs with the largest duration. Currently we put in the priority queue, so it will be um, be in a reverse order, right? So that will be priority queue. Collections. I think that is collections reverse order, something like this. Don't let's try to see whether this one works. So we have a time, right? Time. Then we iterate those kind of courses for each course. Course CY, SC, repositories, right? Now those courses already been sorted by the end time. So let's have the current time equals 0. So we'll say for this course, it has duration and time. So let's put this course into the next big first. Add this course, right? So this course, the duration is course course Z So what's it? If the time plus course duration, right, is greater than its course and time. That means we should get rid of one of the courses, right? So we'll have time minus equal to max q dot top, right? Or full, right? Here, we are also time at equal to plus, yeah. So if the time already greater than the this cost the max time, we just need to get rid of the largest durations. And in the end, we just need to try to see how many courses in the has been stored in the priority queue. Just return max if dot size. Max heap. And G1 S, yeah. Let me see some other test cases. Um, we'll see, we have a sort, right? So that will be n log n for the sort. Also, there is a priority queue that here. The worst case here is that is it, everything put in the priority queue that will also be n log n operation. So time complexity will be n log n, space will be linear, right?